So if we talk about mathematics versus machine learning reality, so in mathematics, you will always have certainty because in mathematics, the rules are fixed. So given input will give exact outputs which we expected. Because let us suppose a mathematical model is there. Now in that mathematical model, whatever inputs you will give, if you give the same set of inputs, always you will get the same set of outputs. But in machine learning, interestingly, if we provide it the data, then the output will be just the probabilistic inference. And now I hope it is very clear to you why is it so. Why certainty is rare in machine learning, why uncertainty is default in machine learning, and why given data for a particular machine learning model like decision tree, random forest, k nearest neighbor, or linear regression, the output will not be certain. Rather, it will be a belief. It will not be the ground truth. It will be the belief. It will be the probabilistic inference. And why is it so? That is very clear to you. The reasons for that. So, one very interesting observation we have to see in machine learning, same data, like I am taking the same data and I am feeding it to the same algorithm. Still, the response will be probabilistic. It will be uncertain. So meaning to say that, let us suppose you have a machine learning model. In that machine learning model, you have a data set. I am calling it K. Now that K data set, you are passing it. In the first time, you are getting an output. Second time you are passing it, the output might vary. For the same algorithm, the same data, K, like data set, the output is different. And that is something very interesting about machine learning. Like, see, in mathematics, though, it's very, very clear that, okay, I have a mathematical model. What's a mathematical model? It can be some set of equations, either differential equations, quadratic equation, polynomial. So I have a mathematical model. I am giving it input. For the same input, output has to be same, 100%. But in machine learning, same data you are giving and same model you are using, output might vary in different iterations. So what's the reason for that? Like, why is it so? So the main reason for that is noise, because the data can have noise and machine learning is sensitive to noise. Mathematical model is not sensitive to noise because machine learning model within it contains mathematics, it contains equations, it contains gradient descent or some sort of optimization. So it contains mathematics within it. Despite of that, it is sensitive to noise because here there is a concept of loss, like the prediction. We are comparing it with the actual. Now, what will happen if the noise will come into the picture? Then the loss will be very significant because of the noise. The prediction will be way far away, like we call it outliers from the actual prediction. So the noise, the loss will be very significant, and we update the weights based on the loss, and that updation will be problematic. It can take the model to a different direction. It can overshoot the global like minima. So many considerations will be there, but the idea is that this noise is something which is problematic. And see, noise is something which is there because human error or any sensor error like IoT data, Internet of Things, there might be some sensor calibration problems. In networking also, there might be some errors which might come into the picture. So noise is something which we cannot like abandon it 100%. It will be there. And because of that, uncertainty will be there. Now, if we talk about programming versus ML systems, so in programming also, we deal with certainty Deterministic, because what is programming? Programming is like set of rules, like whatever code you are writing the fixed rules, and if you give a input, it has to follow those rules, and every time you will get the same output for a given program. Like if I talk about programming, for a given program, or I can call it code, regardless of the input, like if you pass the same input, every time you pass the same input, you will get the same output. That makes sense also. That makes complete sense. So we can say that programming is deterministic. And what is meaning of deterministic? Means I am 100% sure about the output. Like if I have the code, I can say with 100% surety, with full certainty, I can say that, okay, if this is the code I have, and if this is the input, this has to be the output. So that certainty is the deterministic or predictable aspect of programming. But in machine learning, in ML systems, let us suppose you are making a machine learning model. Now, whatever input you are passing, now with machine learning model with us and with the provided input, we can predict the output, but with not certainty. The output is undeterministic. It is probabilistic. Output is probabilistic. We cannot say with surety. We cannot say with certainty. There will always be a chance associated. For example, let us suppose we have a spam classifier as our machine learning model. If we provide it an email, now that prediction it will be making, or the classification it will be making, it can either classify it as a spam or not spam. The but we cannot say with 100% surety that, okay, if this is the email, then this will be the output of the machine learning model. On the other hand, for programming, we can say with 100% confidence that, okay, if this is the code, this is the input, I will just what do you call it, dry run. Like I'll just take the input, and every step I will execute, and I'll derive the output, and I'll tell that, okay, this has to be the output, and when you run, you'll get the same output. But in machine learning, it is not so. And why is it not so? That's a very big question. Like uh, why exactly such a, like, drastic change in the behavior, such a drastic change in the behavior? Why is it so? So definitely we saw many of the factors responsible for uncertainty in machine learning systems. That is, the data is incomplete because the pattern recognition it is doing. The training data set is a sample of the complete reality. So many patterns it is not able to learn. Noise is there, biasness is there, overlapping of features is there. These are factors are there. But apart from that, one more very interesting factor I will tell you. In machine learning, na, one very interesting thing I'll share with you. Humans are unaware of the solution. Now, what it means, humans are unaware of the solution. See, whatever the problem we have to solve in traditional programming, we are the one who first devise the solution for that. Like, okay, this is the problem I have to solve. Like factorial of a number, like very basic example I am taking, factorial of a number. This is the problem I have to solve. Okay, this is the code for that. I devise the solution, I write the solution, I know the solution. And since I know the solution, I can determine the output. But in machine learning, in AI, humans don't know the solution. Because if I talk about spam classification, we don't know how to classify the spam, because it's a very tough problem. Because why it's a tough problem? Because the nature of the input is not fixed. Email is very like a generic scenario. Email can take so many different formats, that the language of it, because there are no fixed rules. There are no fixed rules which we can just code and make a classifier. So many uh, things are responsible in designing such complex systems. So here humans are unaware. We don't know how exactly the spam classification is happening, and that is the black box. So machine learning or artificial intelligence in general, it acts like a black box where humans don't know the exact solution for the recipe, or the humans don't know the recipe. Rather, they rely on algorithms that solve the problems on their own. So this machine learning model, it will first get trained, and once it got trained, it came up with a solution, and we cannot dry run it because we don't know exact formulas and all that, and hence whatever output it will generate, that is like out of the scope for us because it's hidden in the black box AI. So the output is probabilistic, undeterministic. So we covered so many different aspects of machine learning, and we are getting a good feel of it. Like uncertainty, why uncertainty is so common. It's a default in machine learning, that we got a feel of it. And one more very interesting aspect we saw in machine learning systems, the exact solution, we will not be coding it, rather algorithm will be deriving it on its own. And what is that exact solution that we are unaware of? Okay, now we'll discuss reality check in machine learning. Now see, basically when we will be building machine learning models, there are some like few realities which we have to take into consideration. Hardware noise. So if any hardware is involved, like sensor readings in IoT, or camera noise in computer vision, we can also have measurement errors, incorrect labels, human annotation mistakes. We can even have environmental randomness, user behavior changes, or change in user behavior, market trends shift, language evolves. So there might be new techniques which might emerge in the market. The language we are using, it might come up with new libraries, new features, like Python. Like you might be using TensorFlow, Keras, PyTorch. So we might get some very interesting upgradations in that. And because of that, things will change. Now, one very interesting thing we can say about machine learning. So, machine learning models, they learn patterns from a moving, noisy world, not from clean equations. So, this very clearly explains why machine learning systems, machine learning models are different from traditional mathematical models or programming systems. Because, see, in machine learning, data is the most important thing, because if we are training the model, we need data. Now that data we are getting is the real world data. So the data we are getting is from a moving noisy world, especially if IoT sensors are there. If you are getting the data from Internet of Things sensors, so that's a real time data. Or let us suppose social media data you are getting, like clicks and all that, so it's a real time data you are getting. So that real time data you are getting from real world, it's a moving uh, data with noise in it. And because of that, because of the nature of the input, here the nature of the input plays a role, because in traditional mathematical models the input is fixed. Input will not have any noise, there is no scope of noise. Input is from a static word, not a dynamic word, because input will be a set from a set of numbers, it's static. Or in programming also, like you are making a programming system, there also the input will be more of static. But in machine learning, the data which we are using to train the model, it is from the real world. It might come from the real time source. So it is from a moving noisy world, and hence uncertainty is there, because that data is in itself not certain. It can have noises, and that data is a subset. It's a sample of the complete reality. So it is not having all the patterns. So the machine learning model we are making, it is not learning all the patterns. It's learning just a sample of patterns. So there is a chance that if a new input you give it might get stuck because it has not seen those kind of patterns.